Yeah, just had to do a little bop music. Good evening. Think we're continuing our series on cosmic distance ladder. Um, we decided to like move it till tonight because we had a nice juicy conversation concerning the presidential debate. I thought it was pretty awesome. Had some um, people with some very good and interesting perspectives on the debate. So it was fun, but we're here tonight. But before we get started, let me just start with this. Super cute. So yeah, what up, Anthony? How you doing tonight?
Oh, I'm good, sis. I'm good. I can't complain. How about yourself?
Oh goodness, ain't no complaints here.
It's been a long week, but it's about over
It
with.
is. Oh man, it's been a long 2-3 weeks, and I got like 2, 3, 4 more coming, but it's all good. It's gonna be worth it in the end for sure. For sure.
Yeah, I just got to make it one more, one more week.
One
I'm on
more week.
vacation.
I know
Yeah.
that's right. So, part of the introduction, I'm gonna just introduce this. This is what we're gonna be talking about. This is um the cosmic distance ladder, and we're gonna go in order. I think the first show we did a little, kind of overview, basically going over um all of the concepts and just a nice kind of introduction to all of them. This one we were gonna go in order, as science would, and get more in depth in some of the concepts we discussed in the first show when we talk about Cepheids or Cepheids, type 1a supernovas, how you triangulate distant measurements, things like that, standard candles. Um, I hope some of those sound familiar. Talking about light years and astronomical units. And I tried, you know, probably scrambled it up, but to at least, give us some understanding of about distance and space and how that's measured by understanding, how much, what's the distance or time of a light year, how that equates to a parsec, you know, and how that continues on. What's an astronomical unit? All these ways of measurement that astrophysicists use when determining the distance of an object, or how old an object is, like the universe. So, yeah. But anything you want to add to that introduction before we get into our uh, this week's space forecast? Which I think you're outside right now doing something tricky. Yeah, working on some more shots. If you're talking, you muted.
Oh, damn, my bad. Yeah, forgive me, y'all, for not coming up, but I'm outside. It's dark out here, and, doing what I do, looking at the night sky. It's beautiful too. Y'all ought to join me.
I bet it
But
is.
yeah, you laid it out pretty good, there, sis. This chart here is it's pretty, straightforward on the processes that are used in different stages. So
Hmm.
yeah, it's it's really interesting how they determine the estimated distances. And the methods they use are tried and true. Though, and it starts on a very basic level. You can get you have a you remember those protractors. All of y'all that are
Hmm.
old enough, I don't know if they still use them in school, but
Right, right,
we used to
right,
use them back in the day. But
right,
yeah, you can start with one of those and start to measure distances
right,
around the house in your yard or whatever. So Yeah,
Right.
it's pretty interesting how they do this, and
I think
we're gonna
so.
top it off with, huh?
I said, I think it's pretty interesting. Shoot, I even tried to figure out the equation. I think I got it though.
Yeah,
You know what I mean? It's not really that hard. You just got to know the data and how to plug it in. It's
the-
really simple, but I'm probably not gonna go through all that. I'm not gonna squabble that.
well, you just gonna be showing us. You're gonna be showing us how smart you are.
No,
you know,
or how I
you're
be
gonna be
messing
showing
up, or
off.
how I end up getting it. But Barrick, what you doing out there? I need you to hit that link, Barrick. You gonna do the roll call real quick for the
Oh yeah,
people?
we can get that roll call in. Um,
Yeah, roll
Peace to you,
call.
my brother Gary. Yeah, you need to go and hit that link. Chaco Kitty, peace to you. Appreciate you coming through. Scarab
Right,
Chronicles, appreciate you. Appreciate you. We got Miss Bennett, as always, in the house.
Lisa.
Um, the God Killer, aka Bobby Banger, in the house.
Mm.
Peace, bro.
Big Bobby Banger out of Baltimore. I'm
Out of Baltimore, for sure. My boy he about
link
to
in
be
the chat.
immortalized.
Stop acting
Every
like you
time
don't.
we look up in the every time we look up in the night sky, we're gonna see Bobby Banger.
I know
Uh,
that's right. I
Zabri
know that's
West. That's Lil Banger. baby,
right.
baby Bobby Banger.
Big Bobby Banger.
Peace to you, fam. Peace. Appreciate
Right
everybody
on.
coming through. Appreciate that.
Right on. There he go. What up? This is our guest host. Barrick is in the building. You wanna say something to the people right quick.
How's everybody doing tonight? I hope everybody's having a good evening.
Yeah, boy. We having a good evening. A good out evening. Good evening. It's great. It's good. I
Yeah,
hope you're
peace to
having
you, Gary. Appreciate you coming through. Peace, peace.
facts. We pressuring Gary. You ain't gotta be pressured, but I'm saying we like you up here. Shoot. Yeah. So I guess shout out the crowd. Are you ready for that space forecast? Y'all ready for that space forecast? I think we're ready for that space forecast. So here we go.
Hey,
Take it away.
yo, this week's space forecast, we're gonna feature the moon. We got a half moon out. Well, what they call a half moon.
Hmm.
It's actually, we can see a quarter of it. We call it a half, so that's what it'll be. But yeah, that's the sun shining off the moon, reflecting. I mean, the moon is reflecting the sun's light, so it's very pretty too. Out here tonight, where I'm at. If you're in Dallas, Texas, go out and look up. Once again, we got Andromeda rising in the east. Um, we got the constellation of Cassiopeia, which looks like a M or could be a W in the sky. It's pointing right at Andromeda. So that's pretty dope. If you look to the northeast, you'll see the handle of the Big Dipper, which there's a lot of galaxies around there you can see with binoculars. Let's see what else you can see with the open. I mean, oh yeah, you got Saturn about a quarter ways up in the west. No, the east. I'm sorry. Ain't been too long. Rolls up. Looks like a star, but yeah, that's Saturn there in the east. So that's about all we got right now at this time. Got Jupiter and Mars will be rising about 3 a.m. If anybody's up looking to the east, you can see those two planets. Make a nice view. And that's about all we got right now. I'm still waiting on that supernova. I mean that nova to happen. Still
Yeah,
hadn't taken place, but we waiting. We locked and loaded, waiting on it. So
we definitely waiting. Yeah, well, that's a space forecast for this week. So get into it. Yeah. Did you want to add anything, Barrick? Good to go. Guess you good to go. So I guess we'll get into the meeting. But are you going to say something, Barrett?
No, go ahead.
I guess we get into the meat and potatoes. So, like I said, we're breaking down the ladder. I think we should go over some important concepts so people understand how the ladder works. Anthony taught me this yesterday when I had some confusion. So the ladder is each rung is a specific step. We always talk about steps in science, right? If you miss a step or there's an error in a step, you know, it's just gonna mess up the data. It just won't be right. So, the Hubble constant is an important um, is an important um, characteristic in this whole scheme of things, right? Because it sets parameters, especially when they're calculating distance and when they're calculating age, right? In this. So, just like when we talked about the cosmic microwave background and how that sets parameters, and when we're calculating the age of the universe, the Hubble constant is another guardrail, So, things don't go kind of off the road way astray because you have these calculations that have been tested and proven over and over again. So, they become the standard. So we can use that as a safety bar, you know. But today we just wanted to speak on some simple, well, actually, the first step of the rung, which is fairly simple. Um, and the first step, we start with direct measurement. That's the exact first step. So as we move up, and this series will go for like another two, 3 weeks. We have two more sections we're gonna do. Did you want me to announce it, or do you want to wait, Anthony?
No, you can go ahead, sis. It's cool. Yeah,
Okay. I know.
get them.
I asked. I was going to tell you all the things that we have. Two more sections we're going to do after tonight, and then the third section, which will be the last section on the cosmic distance ladder. We're going to bring in again our favorite astrophysicist. I'm going to call him PseudoKillas resident astrophysicist, Dr. Duncan Farah from the University of Hawaii in Manoa, and he's going to deal with that last section, dealing with the redshift, but in reference to the cosmic distance ladder. So if you're interested in this subject and you have some questions and you want to, interact with an expert, then that would be your time to do it. Yeah. So we're going to bring back Dr. Duncan Farrell, and we're going to have some fun, ask some questions, have some great dialogue, and get I call them lectures. I guess people don't like that, think it's boring, but it's what it is. He's literally gonna do a presentation. Maybe that's better. Yeah. A presentation. And yeah, we're gonna get it in and we're gonna hear from an expert doing it. So tonight is direct measurement, triangulation, and parallax. And the specific parallax that we're going to be discussing is a stellar parallax. There are a couple more different types of parallax, maybe a few, more than a couple. We're not going to really get into them. We may extend that another show just on parallax because it's a few of them. But just to get the understanding what the distance ladder is, instead of bogging you down with just a whole bunch of information, we're just going to keep it simple and stick with those concepts. Yeah, so it should be interesting. So before we get started, y'all know I got to do it. I just got to do it. That one had a little bit more groove to it for some reason. Yeah, so I don't know. Did you want to go ahead and add or start it off, Anthony?
Well, it's kind of like I mentioned a few minutes ago at that first rung, which is direct measurement. You know,
Mhm.
that's pretty simple and straightforward. You know, it's like when you can measure something with a tape measure, or you know, like I was stating a few minutes ago, using a protractor to get angles, to get a distance. You know, these are things that you can do in your home, sitting at the house in the backyard. You know, how far away is that tree from your favorite chilling spot? You know what
Mm,
I'm saying?
right.
You can go in the house and get a tape measure and measure that. That would give you that's a direct measurement. You
Correct.
know, if you once you get into like using the protractor and you can break that down, you know, like there are the on the protractor, you know, you have the lines which give you the degrees of arc.
Right.
So if you break that down, okay, knowing that you have 360 degrees in a circle and a protractor is half a circle, so that's 180 degrees.
Right.
But if you break each degree down, you can get to your arc seconds,
Arc
arc
second.
minutes,
Right.
you know, and so forth and so on. So that's basically how the first rung of the distance ladder, you know, is calculated. But you
Hmm.
know that only works for so far. I think you
Correct.
can use direct measurement for so many parsecs,
Right.
and once you get past that, you know, it becomes kind of unreliable.
Right.
So you go to the next rung, and so forth and so on. So that's, you know, that's what we're going to be doing and talking about. And like I
Um,
said, I actually just went through direct measurement, but you know, there's
I like that. Please do.
yeah, that triangulation and parallax would be next. So
Hmm.
yeah, that's the very basic, which things that, like I said, the direct measurement is something we all can do. You know, that's easy. But once we start, you know, getting higher up the ladder, it becomes a little more difficult.
Correct.
And as Miss Juju just mentioned, once we get to the last rung, that redshift, we have to, you know, rely on the expert. Because I know I do. You know, some of y'all may have it, but I don't have it. So yeah, we'll let Dr. Farrar help us with that one. Which is
I
something, you know, he spoke with us a little bit about on the last show.
He did.
The last time he was with us. So
Hmm.
yeah, that'll be fun. But
I
yeah,
think
that's pretty much, you know, direct measurement in a nutshell. You know what
yeah.
I'm saying? Just being able to break down the degrees into, you know, the arc seconds and arc minutes and, you know, so forth and so on. So yeah, it's
Right.
pretty dope.
Um, some more examples would be like, um, you know, the radius. So I'm speaking of things that would be considered direct measurement, and also some of these measurements were made like by some of the earliest astronomers, the Greeks, and how do they say it in the paper with pretty precise measurement, things like the diameter of the Earth. uh, we know that we know the distance from the Earth to the sun. Those things are direct measurement. And it does get a little crazy once the objects get further and further away from us, because it's hard to make extremely precise calculations. And I mean, so you're going to have approximates, and usually when you're dealing with distant objects, especially in astronomy, they're calculating things based off of a crucial property, particularly in stars, like luminosity, because that is one of the best measurements, for distance, by measuring, that brightness of a star, depending on how far it is, and some other attributes to make those calculations. But direct measurement, like you said, is the first letter on the wrong. It's a simple concept. It's things that, are just, there's no question about it. That is a direct measurement. It's an accurate, exact thing. Barrick, did you want to add anything?
Yeah, I was just gonna add. So with each rung on the ladder as you go up depends on the one before it. So at any time, if anything changes in a rung, it will affect the other rungs that are below it. And regarding the direct measurements, like one of the most common things they use is like radar or laser waves to bounce off the planets in the solar system, and that's like how they can tell the distance to Earth. And like you were saying, uh, like the early people, like Hipparchus, he was almost spot on when he calculated his distance to the moon by using trigonometry.
Right. What else is named Hipparchus, since you named that? Do you know?
Mhm.
I don't know, maybe a comet.
Oh, okay. It's in the sky though. You're close,
Yeah,
but
you
the
close.
European Space Agency to do some astrometry. Astrometry. It's a part of astrophysics that deals with, measuring the properties of things like the color, the distance, the size, the luminosity. That's astrometry. So that satellite by the European Space Agency was, what did you say the name is? I'm not going to murder names tonight. Hipparchus.
Hipparchus.
Yeah, it was named that though. And I did provide that in the description for sources on that satellite, because we're not going to get into it. But if you want to have some more information, wait a minute, let me just give you a pretty picture before we go any further, so you can see what the satellite looked like. And while I find the picture, what up, Bobby Banger? I like the people.
What's going on, Juju? How you doing?
I'm good, thank you.
I see you, Anthony. What's going on, man? Mr. Gary, how y'all feeling?
Peace, bro. Peace to you.
How's it going on?
Man, I'm just here for support. No matter how mad Juju stabbed me, I'm gonna support her until she come back. You don't. no matter how, no matter how mean you be to me, I'm be right here for you. I'm in your corner. Y'all, I appreciate your hard work. You and Anthony, I think y'all got a spectacular show. So I'm here. Man,
I don't know what he's talking about, y'all.
I know, man.
Yeah, appreciate you coming through, bro. Appreciate
Yeah,
it.
No,
we
tough
appreciate
topic though.
that. Eh,
Tough topic. Tough topic. Yeah, I got my book and stuff out. My
oh yeah.
yeah, I got it. Take
Oh
it.
yeah.
I want to learn. I need to. That's a good one.
Yeah. It is. It it's a good one because when you're dealing with the cosmic distance ladder, I put a paper in there. I actually got a few fun things, but I put a paper in there that is pretty awesome. And it explains like the importance of the cosmic distance ladder, right? Um, so it says some things like, so by the way, it's also called extragalactic distance scale. That's another name for the cosmic distant ladder. So when you're doing your studies and you see that, it's the same thing. So, I'm gonna mention it because I was, oh, they told me that, they're not PseudoKillas. No. So I'll be trying not to miss no steps because I know it's people watching ready to crush, you know what I'm saying, on little minuscule stuff. But this is the extragalactic distance scale known as the CDL. not your commercial driver's license, but the cosmic distant ladder.
Hey, but that's a good point, though, sis. That's a good
Right,
point.
right. So it's a crucial concept in the field of astronomy. Um, like we said before, it's a series of methods which astronomers determine distances to celestial objects. It says two because our vantage point, our orientation is always going to be Earth, our mother, right? So that's why I say distance to celestial objects, because it's always from the perspective coming from Earth. The CDL, not the commercial driver's license, is not just a what is this? A tool for measurement. It's the cornerstone of our understanding of the universe and its vastness. So when we talk about the cosmic distant ladder, this has been one of those things that have been at the foundation of astrophysics, of understanding the universe we live in. um yeah, so this would definitely be one of the fundamental important things one should know if they want to have a good understanding of astrophysics, I think. So um I left that paper if you want to read more. I don't want to go too far, but the field is very important. Very important. Again, because when we talk about distance in space, we're also talking about time, space time. It's different when you're dealing in astrophysics than when we're dealing in our reality of time. It doesn't equate to space in the same sense it does in astrophysics, the universe. So I like to always make that point so people don't get confused. Barrick, did you want to add anything?
No, I'm just waiting for the next steps.
Okay. So we just told you about direct measurement, which is very simple. There's really not much else to say. So, I mean, I couldn't prolong it if I wanted to. And I found this neat. I thought this was a neat diagram. There's a few, and I'll show a few different visuals. And we'll get into parallax. Is that what you're waiting for, Barrett? Because if you were, I'm gonna let you go ahead. Because you're good at this. Go, Barrick. Go, Barrick. Go.
Yeah. So the parallax is where they will take a picture of a star, like say in January, and they will wait till the it does a half 180 circle and say June 1st. Then they'll take another picture, and then what they'll do is the stars that they're looking at change in regard to the other stars behind them. So what they do is they measure the change of the stars behind them, and then with that, that's called the parallax angle, and then they can use trigonometry to find out the distance of the star.
I like that. Before Anthony go, so this particular diagram of the parallax. So again, I told y'all there's different ones. We're going to deal with stellar parallax, and this is like the distance of a star from the orientation of Earth. And like Barrick said, they're going to take a measurement. So because we know a direct measurement, that first step, then we can do the second step. You see how that works? So the direct measurement is that we already know the astronomical unit. That's another unit of measurement that astrophysicists use, and that is the distance of the Earth from the sun, which is 1 astronomical unit. And then that has another numeric quality, but because astrophysics deals in such vastness and large quantities of numbers, the numbers can go across the room. So they do things like adding parsecs and astronomical units to make the math, easier to calculate or easier for other people to actually understand, because it's hard to speak in, God, trillions. You feel me? It's hard to write that out. So we know 1 astronomical unit is the distance of the Earth to the sun, and that's going to be your baseline. So they do it in January in one direction. So the sun is going to be the blue dot, and then Earth is the blue dot. The sun is the yellow dot in the middle. So from the Earth, that's on the outside, going to a straight line to the sun. That's one part of the baseline. And then they wait 6 months later and they do the same calculation because the Earth is going to be in the exact same spot, but on the other side. Okay. So you see Earth down here and you draw the straight line to the sun. So from one Earth point from January to the other Earth point in July is your baseline. That was your direct measurement. So that gives you your first step in how to calculate the parallax. Okay. So now the parallax happens, the parallax angle, that's the measurement, is when you take the line from Earth to the star from January, then the line from Earth to that star from July, 6 months later. Then you have the baseline. Then you have the two lines from both sides, and you make this triangle. And then in the middle, if you take from the sun and go straight up that triangle, that's gonna make like these. I'm not gonna say they're right triangles, but what isosceles triangles. And then you can calculate the parallax angle from that. Okay. That equation was in the thumbnail, and this distance equals 1 over p. All right. And I ain't gonna mix it up, but the distance is in parsecs, and the p is in, dang, I already forgot it. It's another one. So let me go through this. So I think that's interesting because they call it they call it a word. It's like a parmonitude, which is they actually take. Oh, it's an arc seconds. I know I'll get it. I have to explain it a certain way. So the distance is in parsecs, but the p is in arc seconds because parsecs parsec, the word is parallax and arc second, and they take a portion of each word and they combine it and you get parsec. All right. So if you read up on parsec, it'll tell you that. All right. But that's how we can calculate the distance of a star from the orientation of Earth, by having the tools of direct measurement and by using parallax. Anthony, did you want to add anything?
Yeah, sis. I just excuse me. I just emailed you something. See if you can pull it up real quick.
Okay. Well, I like when
And
he emails me
what
stuff.
now, this, both of y'all hit it, dead on. It's the, when you take knowing the distance from the Earth to the sun, and understanding that the Earth revolves around the sun, it orbits the sun. We can find a baseline star, and we can take a picture of it on one side of the Earth, like you say, in January, and then come back in July and take that picture. And based on the background stars, we can use this method that's on the screen to get the movement, or what appears to be the movement of the star we're studying versus the background stars. Now, when you using a simple protractor, and this is what's shown on the screen, there, when you break it down, as you can see, 1 degree, if you take that 1 degree and you break it out into 60 parts, you know what I'm saying? You get 60 arc minutes. And if you take an arc minute and break it down into 60 parts, you get an arc second. So those little lines, that's how they're going to measure the star versus the background stars. And that'll let them know how much, it moved. If it moved 1 arc second, that's how they can tell that's how they can gauge that movement. So there are certain stars you can use, though, that there are high velocity stars and stuff like that. That's how they can tell, the different, if a star is moving, if it's, the direction is coming in. But most of all, what we're speaking on is the distance. So this is how they break that down, from a degree to arc minutes and arc seconds. And like I said, there's 360 degrees in a circle. Well, if you take that and get you the arc seconds, now you have what, 3,600 degrees? I forgot what they multiplied by, but you get the picture. If you just not study it, but understand that it's the movement of the star every 6 months that gives them the distance, based off of this formula right here. The first rung of the ladder. And like Gary was saying, it has to be right. You need one step to get to the next step. And if the numbers, like Ms. Juju said, if the data isn't correct, it's gonna mess everything up coming, after it. So each step depends on the previous step being, pretty accurate. And they've mastered this. They got it down to a science. It's pretty, it's what we got, put it like that. It's
Right.
what we got. And it's really helping our understanding of the cosmos,
Sorry.
Yeah,
But yeah, it's a great tool. It's one of the tools that we use it's one of the tools that we use to get our understanding. That's what science is all about. Creating tools to help us understand the natural world. And this is one of those major tools that we need and we often use to come to that understanding. So parallax is very important.
God, I'm mute.
And
I wanted
trigonometry.
to show this really quick. It's a quick demonstration of what we mean by parallax also. I think I should have showed it earlier, but I still wanted to give you all a visual on what parallax is and why they call it that and how we can measure distance. And this is just a short explanation, okay? So.
And what I mean by parallax, I'm going to have you do a quick demo. I'm actually going to have you hold your thumb up very close to your face like this and close and open each of your eyes back and forth just like that. And as you do that, you can see that your thumb, the position of your thumb, moves a lot compared to whatever background you happen to be looking at. So that probably looks something like this when you hold your thumb up in front of your face like that. What I'm going to have you do next is hold your thumb very far away from your face like this and do the same thing. Just open and close each eye and observe how the position of your thumb compared to the background that you're looking at changes. When you do that, it probably looks something like this. The position of your thumb changes a little bit, but not as much as when it was very close to you.
Right.
This is the parallax effect. This is what we're going to be talking about throughout the lecture. Parallax is what happens when the position of an observer changes, and as a result, the objects that the observer can see change their position in the observer's field of vision in comparison to farther away objects that don't change their position as much. We experience this effect all the time when we go outside and begin to move more quickly. Objects that are closer move more in our field of vision compared to objects that are farther away. Here, this tree is moving a lot. The mountain is actually moving a tiny little bit, and the sun is not moving at all. So just looking at this animation, your brain kind of automatically assumes that the tree is closer than the mountain, and the mountain.
I think y'all get the idea, but that is a parallax effect, and that is what's happening. So yeah, and they realized this, so then they found a way to calculate certain things off of the effect and to measure distance. But that, same thing happens. Yeah.
And that's where the astronomical unit is important, because now you can put numbers to it.
Direct measurement.
Mm-hmm.
Yeah,
Yep.
I wanted to add on some of the terms or some of the equations. An astronomical unit is 150 million kilometers, and that's what the difference, or that's the distance from the Earth to the Sun. That parallax angle, is always less than 1 arcsecond.
Mm-hmm.
And like Anthony said, 1 arcsecond is 1/3600th of a second. And there's a satellite named Gaia
Mm-hmm.
that it uses the parallax measurements, and it's mapped out. It said over 1 billion different
Mm-hmm.
objects in our Milky Way just by using that parallax measurements.
Right.
Yeah. And that's the successor to Hipparchus.
Yeah, Hipparchus did the same thing, like 100,000
Yeah.
or
But
something.
Gaia, Gaia is his
Gaia
big
took it
brother.
over there. I know. Gaia took it over there. I just wanted to show a pretty simulation. I thought the simulation was awesome. Also gives you this 3 steps measuring the expansion rate, which is something that cosmic distance ladder can help with also.
Yeah. Yeah.
Using similar things. So yeah. It's a powerful thing in astrophysics. Yeah, these is probably one of the in the bag of the important stuff. This is in that bag, definitely. You need this.
Yeah, most definitely, that's sis. I mean, you couldn't have said that no better. I mean, this helps bring so much understanding, because I mean, let's just be real. We're not gonna leave the solar system. No time, not a human anyway. No time soon. You know what I'm saying? So we have to have a way to get these measurements and understand the vastness of space. I mean, it's the cosmos, man, is oh my goodness.
Right.
You can't begin to fathom the distances between things. It's the moon is 200 and over 200,000 miles away from us. That's and some nights we can go out and look like we can just reach up and touch it. You know what I'm saying? It looks like it's so close, but those distances, man, I mean, there's no way we can actually, measure the distance to Andromeda. So we have to find a way to be able to do that, because we can't go there. It's not going to happen in 2 or 3 lifetimes. So that's what makes this method so powerful. It gives us an understanding of the vastness of the cosmos. It's deep.
It is
Yeah,
deep.
Anthony. Yeah, Anthony, and I was gonna say that's why I don't understand. Elon Musk is, on the frontier and he's leading, the way, and his answer to get to Mars is with like a chemical rocket. It's like for us to get out of this solar system, we're gonna have to figure something out that's not, a chemical.
Right. Well,
Yeah, we
Elon
won't be able to take our fuel with us. Because
right,
that'll make the rocket be too big to leave the Earth then.
correct.
So,
And Elon Musk is not a scientist. He's just a man with a lot of money. And I think people need to understand that.
yeah.
Yeah, that's it. So, it's like what when people are like, things can be intuitive. He's probably suffering from a type of confirmation biases, but because he has money, so just people just think everything he says sounds good when actually it's not going to work at all. you know, because he doesn't understand the science. He may understand some things, don't get me wrong. It's like when we spoke to Gina Page, you know, she wasn't the geneticist, but she definitely had, you know, a handle on it. But there's some things that, you know, she wasn't going to attempt to answer because she didn't know and she knew her limitation. So, and I don't even think Elon Musk has it that good, but yeah.
Well, yeah, you said he got a lot of money, but he's smart enough to hire the right people.
He does have the right
To
people, but if they're telling him that, then
yeah,
I don't know.
it,
Like I keep
it's
telling
totally
y'all,
riding.
that
It's
Boeing
totally riding
Starliner,
on those people.
right? Like I told you, that Boeing, I'm not too smart, but when I know something ain't smell right, I know it. The Boeing Starliner, boy, I told y'all, Boeing don't need to be putting nothing in space until he get his problems right on Earth. And look what happened. We got a
Yeah,
mess. I'm just
that's a
saying.
fact.
I told y'all, got them people stranded. Let me stop. I'm just kidding. No, I'm not. But yeah, that's it. But is that it? Did y'all want to add anything else? That's pretty much it. You know, I can't even bog you down. That's the information. Um,
Yeah, for the first, the first few steps. Yeah,
yeah,
we'll dive into the next section next week. Yeah, we
definitely.
wanted to keep it simple and get that baseline understanding.
Mm-hmm.
So y'all remember astronomical units and parsecs, and then we'll be ready for the next section.
Okay, so before we go, I do have something fun for you all. I want to see if y'all want to participate in a little brain brawl. I'm so goofy. Yeah. Yeah. Ain't this cute? Y'all like this? I don't know if I give it to y'all, but the people that are in the Discord, I will give this to you for sure. Okay. Let me see how it works again. How did it do it? Yeah, that's how to. Okay, so what are some of the rungs on the cosmic distance ladder? And maybe whoever gets the most answers, maybe y'all get a lunch card. You know how I like to do that. I'll get you lunch. Lisa, how was your lunch? I know it was late, but you know, how was it? Tell the people. So, what are some of the rungs on the cosmic distance ladder? Let's what it say. Trigonometric parallax, spectroscopic parallax, Cepheid, RR Leray variables, Tully-Fisher relation, or type 1a supernova. Does anybody want to take a stab at that answer? God Killer, you want to take a stab at that answer?
Nope. What's that? What did it say? What did it say?
It
I
said,
can't even see it.
it says, what are some of the rungs on the cosmic distance ladder?
Some of the
And
runs.
rungs, you know, like the
Oh yeah.
steps, rungs, steps.
Oh.
It's it would be, these are the different rungs actually. How does a trigonometric parallax work, and what distance range does it cover? Anybody want to take a stab at that?
Nope.
It's the let's see what it says. I'm gonna give it away. Involves measuring the annual change in position of nearby stars. We talked about it, y'all. Relative to
Yep.
background in the course of a year. Accurate for only the closest objects, no more than 1,000 parsecs away. So this would be like within, you know, the next step after direct measurement, y'all. How does spectroscopic
See, they must have
parallax?
been asleep, Miss Juju.
That's
That's not good,
triangulation.
huh?
That's triangulation.
Which
Yeah.
one? This one?
The one,
Which one, Berg? This one? How does trigonometric parallax, or what I said?
yeah, the trigonometry one is triangulation.
Right.
Mm-hmm.
Did you want to explain that?
No, I thought that was the question.
Well, you can't get the lunch though, Gary. You Gary trying to get the free lunch,
Oh,
Miss
my
Juju.
fault. My fault. My fault.
It's all good. I'm confused. I'm a spectroscopic. So we probably covered this on the first show we had on it, but how does Cepheids or Cepheids and RR Lyraes work, and what distance ranges do they cover? Let's just see.
Mhm.
I'm just trying to get it right. They're variable stars. Remember we talked about Cepheids, variable stars that pulsate, right?
Yeah.
And these pulsates are accurate and measurable. Yeah, right? Yeah.
And the only difference between the two, the Cepheid variable and the RR Lyrae,
Mhm.
is the Cepheid variables are more like field stars, like our sun. They're out there by themselves pretty much. But the
Mhm.
RR Lyrae, you find those in globular clusters, and that's going to
Mm.
become important later on as well.
That sure is. Let's see what the next one says. How does the Tully-Fish relation work? And what distance range does it cover? Just because I had read some before. I got this on the multiple choice, but it relates how quickly a spiral galaxy is spinning to its luminosity. More massive galaxies rotate more quickly and have more stars, so they are more luminous than less massive galaxies. By looking at the rotation curve, you can estimate its mass and this luminosity, giving a distance. A good out to a few hundred megaparsecs MPC. That's megaparsecs, y'all. Or is it mega or milli?
Mhm.
MPC, milli or
It's
mega?
mega.
Mega. Okay. I thought so. But fairly imprecise. Let's see what the next one is. What does it tell you? Okay. How does type 1A supernova work, and what distance ranges does it cover? So this goes into all of them. I won't go, but it's this neat little gadget here. Like, oh, I did good on the match, y'all. I did good on the match. So yeah, I have this neat little
Pretty
game.
dope there, Miss Juju. What is that?
Yeah, I don't know how I find it. I don't know how I found it, but I thought it was interesting, you know. So you can go through it. You can go through it. Yeah, this is the one I did good on. See, I was good at the multiple choice, y'all. I think it would be this one. See? Yeah. So yeah, y'all can figure it out. I'll share it with y'all. But yeah, that was pretty fun. Do I have any more visuals for you all? Great job, Eric. Thank you. Really good
Yeah,
at
good
this.
job, bro. Appreciate you, man.
Shoot, about to make you a host. I'm just borrowing time because I thought this was pretty awesome. I didn't get to show it. I'm gonna show it next time. But I thought this was a good representation of the ladder, and it gave a
Oh yeah.
very comprehensive breakdown, short but precise at the bottom. So this is some neat stuff, I'm telling you. I had it backwards yesterday, so I was kind of like, yeah, let's postpone it because I have my wires crossed. But once I realized, and it's like, oh, and put it together, I was all right. It was good to go. So
That's nice, sis. I like this here one.
oh, you like this?
Yeah.
Yeah, boy. So what lunch
I
was
need that
great.
for my personal stash. I need you to send me that.
Okay. Let me see what it is. Let me go ahead and get that for you now. So I don't forget. Copy. Grab it out the Discord because that's the easiest. I'm gonna put it in our Galaxy and Beyond for you. And anybody else in the Discord who want it, you just get it from there. There you go. You got it. Oh, let me go ahead and do the game. I'm gonna send y'all this game. That was so cool.
We got a few done came in the house too. Peace to you, brother Sosa. PseudoKillas 50.
PKO. What a Sosa.
Oh, Tito. Peace to you, bro. Appreciate y'all joining us.
But y'all know I love interactive, so I figured this is something you can also have fun with your kids or make it, adult little game at the cookout barbecue, whatever. But y'all could be super, super, super smarty pants with it. You feels me? So yeah. Sorry, I put my glasses on, so I'm all in the thing like, I'm sorry, y'all. I was like, oh man. I was grooving. I didn't want to stop the groove. I was like, forget it. I'll get it. But yeah, that's what we got for you. Well, that's all I got. Any final words, gentlemen? What else y'all want to do? What up, Odio?
Well, you know me, sis. I'm always it's the same thing with me, y'all. Protect your intellectual property. Please do. Don't let the
Right.
pseudos have it.
Oh my God.
Yeah.
No.
I know this one of those subjects, it's kind of slow, but for me it's wonderful. I guarantee you, if you could just find the time to take the time to look up in the night sky, man, it'll amaze you.
It's
You know,
fascinating, bro. Fascinating.
I
So it's not
encourage
that it's
everyone to
slow.
keep looking up.
It's not that it's slow. It's just ain't for everybody. And
Oh yeah, that's a better way to put it.
yeah. And it ain't for everybody, then maybe y'all ain't on the top of the food chain. I don't know. Let me know. Let me stop. Let me stop. I'm just playing. I'm not. Barrick, you got some final words for the people?
Hope everybody has a good evening, and we'll get on to the next show and get into more of the interesting steps. I like the next step that's coming up. I like those the best.
Ooh, well, tell the people what the next step gonna be, Barrick.
That's the one where you have your standard candles, your Cephids, your 1A supernova, globular clusters, all of that.
Oh, so you ready, huh?
I'm been ready.
Oh, y'all heard it from Barrick. He's gonna be leading the show next week. Me and Anthony taking a vacation. Yeah, no, but y'all get comfortable with Barrick because as long as he wants to be,
It sound like it.
he's gonna be here. We gonna let him. We
Yeah,
like Barrick. You probably gonna turn from a guest host to a co-host.
we're gonna let Gary do it.
Is he gonna let Gary do it? But yeah, is there any questions in the chat before we get on out of here? I don't see none. I don't see no questions. Yeah, so are you taking notes in the chat, Valisa? I see you. It's like you taking notes. The simulation was nice. Thank you, sis. Gene, Scarab Chronicles, you ain't gotta apologize to nobody, okay? Like it's the what is that? Everybody can get it clan. You feel me? The Mexicans, the Africans, the pseudokins. Everybody can get it. Something, whatever Bobby Bang be saying, something like that. But yeah, girl, you ain't never gotta apologize. You feel me? But that's all for tonight. Thank y'all for joining us. We appreciate all the support. We appreciate those who have been supporting us steadily. Thank you so much. Yeah, this has been another PseudoKillas production. And did you want to leave them with your quote, Anthony? What's your favorite saying?
When you're scientifically literate, they can't drag you down to their level and beat you up with experience.
That part. We out. Bye.